One of the things that we like to do when we run across a plane curve is to try to sketch the graph of the curve. And the most straightforward method, or at least initially the most straightforward method, is to do that by completing a table. Remember that a plane curve includes parametric equations describing x and y in terms of a parameter, in this case t, where that t, that parameter, runs over a certain interval. So complete a table and sketch the graph x equals 2t, y equals 3t minus 4, where t is between -5 and +5 inclusive. So what we would do is we would complete a table. So we need to pick some numbers for t, and they need to be between -5 and 5. And we could pick, for instance, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Of course, there's nothing special about these numbers, but they are in the interval, and they do make things pretty easy to calculate. So just to do a couple of examples explicitly, if t is equal to -5, we are told that x is equal to 2 times t. So x would be equal to 2 times -5. Which is -10. And y is equal to 3 times -5 minus 4. We're just doing the substitutions there. 3 times -5 is -15. Minus 4 is -19. So if t is equal to -5, x is equal to -10, and y is equal to -19. Okay, if t is -4, then x is equal to 2 times -4. Again, we are told that x is equal to 2 times t, y is equal to 3t minus 4. In that case, x would be equal to -8. And y would be equal to 3 times -4 minus 4, -16. So we can include that in our table. So if t is -4, x is -8, and y is -16. And we go down the line completing the table. So if t is equal to -3, then x is -6. And if t is -3, then y is -13. If t is -2, x is -4, and y is -10. If t is -1, x is -2, and y is -7. If t is 0, x is 0, and y is -4. If t is 1, then x is 2, and y is -1. If t is 2, x is 4, and y is +2. If t is 3, then x is 6, and y is +5. If x is 4, then if t is 4, then x is 8, and y is 8 as well. And if t is 5, x is 10, and y is 11. In this way, we have filled out a table, and we have x and y coordinates that we can put on our graph together. So we have x is -10, y is -19. So just for the sake of being able to put the points on the graph, let's say that every mark is 2. So let's say this is 2, 4, 6, so on, 2, 4, 6. Okay. So if x is -10, which 2, 4, 6, 8, 10 would be there, y is -19. So that would be down here. So this is the point, -10, -19. Then we can put the other points as well. We keep going. -8, -16. So that would be here. -6, -13. Notice that I happen to be putting these points in order of t increasing. So t starts with its smallest value, -5, and it's increasing up to its largest value, 5. So where are we? -4, -10. -2 and -7. 0 and -4. Now that we know that each mark represents 2, I'm going to go ahead and erase that for a moment to get it out of our way so we don't clutter up our graph. 2 and -1. 4 and 2. 6 and 5. 8 and 8. And finally, 10 and 11. So here are the points that we have plotted, and it seems fairly clear that our curve starts down here in the bottom left and travels up to the upper right. And we do want to, even though we may not put exactly which t goes with which point, we do want to indicate the orientation of this curve, and so we put some arrowheads. It starts down at the bottom and it travels up and to the right, so we indicate with some arrows. There's the orientation. So here's an example of a plane curve sketched using a table. Notice that this curve does have 2 endpoints, and they are distinct, so the curve is not a closed curve. The endpoints are -10 and -19, and 10, 11 are the endpoints. Here's an example of a closed curve sketched using a table.